Hello everyone. So in today's class we are going to start new chapter that is wave optics. Okay, what is that? Wave optics. In this chapter we will learn about light and basically light as a or light has wave nature. Okay, so this type of thing means particularly this nature of wave, light we are going to study in this chapter that is wave optics. In ray optics we have learned only the light travels in a straight line, that concept. Okay, that is in the form of straight rays. So in this chapter we are going to learn all phenomena which describes or which proves that light has wave nature. Got it? So let's start from Huygens wave theory. Okay, what is this Huygens wave theory? First point, you see, a body emits light in the form of waves. According to Huygens, what he is saying, body emits light in the form of waves, and each point source of light is center of disturbance from which waves spread in all directions. So any point source of light, suppose this is a point source, so from here waves will get spreaded in all possible directions. That is what second point. Okay, next question I have written here, what is wavefront? What is a wavefront? The locus of all particles of the medium vibrating in the same phase at a given instant is called the wavefront. So let us take one example. You did this so many times. So let us suppose this is, let us consider a lake, and in that you have dropped this stone. So then when you are dropping the stone, what happens? This concentric circles, what it indicates, these are the generation of waves on the surface of the water. Even you do one thing, take a vessel, yes or not, take a vessel like this and take water bottle or something like that and just drop some drops of water or oil or whatever it is in this, then you will see that in this liquid you will get some concentric circles. Understand? So these are nothing but what? Waves spreading out on the surface of water after a stone is thrown. You can take a stone, you throw in the vessel, or small stone. Don't throw big stone, otherwise it will break. Okay. So just small stone you take and do this activity. You will understand what is the wave front is. So what is its example? Its example is wave spreading out on the surface of water after a stone is thrown. You just imagine, close your eyes and just see when tap sound is coming, how that waves are going to spread on the surface of water. Okay. So next one, wavefront can be defined as surface of constant phase. Another definition of wavefront. What is the another definition of wavefront? Wavefront can be defined as surface of constant phase. Means we are considering one surface which is having a constant phase. Okay, that is what your wavefront is. Okay, so let's move ahead. Now you see here I have drawn one diagram which indicates wavefront. So you see this locus of all points, this one. This is what? Of same phase. This one is of same phase. This one is of same phase. So this is nothing but locus of all points which is having constant phase. That is what your wavefront is. Now what is the phase speed? Okay. What is the phase speed? See, wavefront is moving with one particular speed. Okay, agree with me? Because when you are dropping the stone into the water surface or into the water or on the water surface, whatever it is, so when what will happen then, there this wavefront will move ahead. It will have some speed, yes or not? Yes. So that speed with which this wavefront moves, that is called phase speed. Okay, that is what your phase speed is. Continuously it will go on. So you see, you just do that activity if you have time. Take one vessel. Yes, take one small stone, right? Small stone you take, drop it, but be careful. When you are dropping or you are going to drop, just water should be steady. It should not shake. Just let it come at equilibrium position. So no water should move from that container. Just take it and slowly you drop, and slowly you will observe that wavefronts are moving on the surface of water. You will easily understand this part. What is phase, speed, and wavefront, and all these things. Okay, right. Next, energy of wave travels perpendicular to wavefront. This is another point which I have given you. Whatever the energy is there of that particular wave, travels, how it will travel? Perpendicular to wavefront. See in the diagram I have shown below. This is what the direction of energy. See here how it is. Every point it is perpendicular for the wavefront. You see, perpendicular. This is what energy transmission takes place, or this is how energy transmission takes place. Right? Understand? This is what energy of wave travels perpendicular to wavefront. Next, note point. You see, I have given some note points to you or for you. Every point on a wavefront is an independent source to produce secondary wavelets. What is the meaning? See here, this is now wavefront. On this is point is there again. So this point again behaves as a secondary source which produces again wavefronts. Understand? Next one, all points on a wavefront vibrate in a same phase with same frequency. So these all points here you see, all points they are having same frequency and they are in the same phase. So whatever the particles or points are there, all are in same frequency having the same phase. Next, wavefronts move with the velocity of wave in that medium. Already I told you, yes, the wavefronts move with the velocity of wave in that medium. So with what velocity that wave is moving, with that velocity only the wavefront will move in that particular medium. Got it? Means that concentric circles how they are moving. Yes, with the same, that is what the wave speed we can say, or velocity of that wave in that particular medium. So pause the video every page and note down each time carefully. Draw the diagrams as it is. Right? Understood? Okay. So let's move ahead. Now, see here, shape of wavefront. So every time will I get like that shape only? Because I told you one example of water. Okay, sir, understood how the wavefront is getting formed on the surface of water, how the waves are transferring. Okay, wavefront is moving, wave speed understood, everything understood. But is it necessary that every time I should get like that wavefronts only? Yes, because we are not studying water here. We are studying what? Light. What we are studying? Light. And therefore, light has or light source has different shapes, and therefore the shape of wavefront will also change according to the shape of the light source. Okay, so let's see first one, that is point source. If we have chosen a point source, then its wavefront is how? Spherical wavefront. You can see in the diagram how I have drawn. So this is your point source from which light is going to emit, and at this point this is the locus which I have considered of all points which are having same points and same frequency. Then the nature of this is spherical. So wavefront is what? Spherical wavefront. For which type of source? Point source. Point source, spherical wavefront. Next one is line source. Line source means like a tube light. Hai na? Tube light is what? Line source. And now see, if that is line source is here somewhere, and then around it how the wavefronts are going to generate, then the wavefront shape is how? cylindrical. You can see in the diagram. Yes, can you see? You have to draw this diagram. And if suppose source is at infinity now, for example, sun is at infinity. It is very long. Okay, then the nature of wavefront in such a type of, or for these type of sources, we can say it is a plane wavefront. And how it is? See here, this is one plane, and how the light or whatever the wavefront is there. Okay, and one more point I have given below, that each point on a wavefront is a source of new disturbance called secondary wavelength. So if you will see here again this point, because this point is on the wavefront, so again this will behave as a secondary wavelength. So means from that point, means actually it will behave as a secondary source of light, we can say. Here it is primary source of light, and here again it is a wavefront. So again from here again it will get distributed, again it will get distributed. So this will behave as a secondary source of light. Is that clear? Understood everything? Yes. Okay, so this is what for today. Note down clearly, pause the slides, and write down notes very carefully, because this is a new chapter. Okay, if you have any doubt, direct call me. Let's stop here for today. Bye.